let's continue studying a little bit more group by and looking at pivot tables, which are a concept that was introduced in Data 8 and that we're briefly going to review in the context of how Pandas implements it. So let's imagine that we want to learn how many babies are born each year of either sex, since we do have birth sex data in the data set. One option would be to do it by grouping on both year and sex. It turns out that the group by operation doesn't have to be done on a single key. Now, this introduces a slightly more complicated concept, which is that of a multi-index. If we say group by year and sex, this is what the resulting data frame looks like. And if you see, the index now has is basically a two-level index. Pandas is perfectly content with this. These are called multi-indices, and we'll take a little bit of a deeper look at these off lecture over the next few days. But multi-indices are a two-level or a multi-level object, which in this case first has the year, because that's the order in which we gave it, and then for each year it actually represents both values of in this case the data aggregated from the sex column. And after that, we can just tally up a count. So this does give us that information, but there is an alternative approach to do this, which is to represent it in perhaps what would be a more natural layout for this kind of data, which would be to say, well, for each year, I would like a column for each of the two sexes that are registered in the data, and for each of those, I want to have the total count. It turns out that this kind of table can be produced by using the pivot table method. In this case, a pivot table is an operation that is similar to a group by, but slightly more complicated. It's kind of a generalization of a group by. So the pivot table method takes several arguments. We tell it what do we want to have as the rows in our resulting table. In this case, we want our rows to be indexed by year. We want the columns to be the values of the sex category. And then what do we want to actually fill it with? So in that case, what we want to do is we want to use the data from the count in the data set, but not just all of the data. What are we going to do to group all of that data? We're going to aggregate it with a specific operation. So let's take a look at how that works. So if we call simply a multi-index group by, this is what we saw that we would obtain. Just to clarify, this is what happens. This is order sensitive, right? The levels are order sensitive. So if we say I want to group by year, then by sex, my multi-index will first have the years, and then within each year, it'll give me all the categories. Whereas if we do the opposite, if I ask for a multi-index, a multi-category group by, where my first category is sex and my second category is year, now I'm going to have, in this case, female first, and I'll have all the years, right? And then I'll have male in all of the years. So in this case, since we're only looking at the first few, we don't see the rest of the data. Let's remember that this was the complete structure of the data set. We have, we're only looking at California, but we have sex, year, the name itself, and the count for that year for that name. So we can actually group by multiple levels. This is a slightly more complicated one. And the result here, that one took a long time to run, and look at the strange result that we got. Well, in this case, we asked to keep, we asked the group by count, year, and sex, and then we called on the remaining data, we called sum instead. And so what happened was, for the remaining categories, what Pandas tried to do was imagine we've aggregated by count, then by year, then by sex. And so the remaining, which are these, count, then year, then sex. And then we have the state, and we have as many occurrences as there are for count 5. The number 5 appears many times, right? Because it's the minimal, the the number for kind of rare any rare names, and there's a lot of those there. And so this one is going to appear probably every year. There's going to be names with 5 occurrences. And if we call sum on the remaining fields, what it's going to do is concatenate, because adding 2 strings does make sense. Subtracting strings, as we saw earlier, doesn't make sense, but adding them does. And so in this case, it's going to concatenate the occurrences of the state, which is obviously CA, 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 etc. And then it's going to basically stitch together all the names. This is a stitching together of all the names that in 1910 for females appeared 5 times, and they're stitched together in here. Not a particularly useful thing perhaps to have, but it does illustrate how these multi-level indices operate. Now let's try to answer the question again of how to find the number of babies born each year of each sex, but instead of using this one, instead of using this multi-index approach, let's try to have our let's try to build our pivot table. So if we want our rows to be the year and our columns to be the sex, and then we want to add up the counts, this is how we would express it. This is how we would express it. And in this case, we have now constructed in one single call. We get exactly the information that we were after. Now we can actually keep more information than just the count. Let's say that we wanted to keep count, but also name. So in this case, what this is telling us is not only what is the count of the number of babies born, but by using but also what was the most popular female and male name in that particular year. So this is the kind of information that is a fairly complex kind of distillation of data from this entire data set, but which a single call to a pivot table does all of the wrangling to provide this summary. And this picture is a bit of an illustration of how it works, and it shows visually, if you understood the previous description of how Groupby works, then this one should make sense, with the added fact that in this case with pivot tables now we actually have a new dimension in the output, which is that we control the layout of the columns differently. So a pivot table operation specifies what is going to go in the index, but we also group by effectively a second set of keys, which is the column key. And so now, in this case, we've labeled the row keys with blue and the column keys with red. When the pivot table call is made, a grouping operation is made, and these subframes are created just like we did with Groupby, but now in this case for every combination of row and column. So for example, it finds which combination of row and columns exist. AF, there appears twice, so you can think of these two together as one subframe. AM appears only once, so this is another subframe that happens to have one row. BF is another subframe, the third. BM appears is the fourth subframe that has 2 rows. CF the fifth, CM the sixth, and DF the seventh. So we end up with 7 different subframes that are present in our Groupby when we combine row and column keys. Now, at this point, we also select, if you look here, which are not just the rows and columns, but which are the values that we are going to keep, because you can tell in this case there's only 1 column of values left, but in our data set there were actually more than 1, so we can tell it which values to keep and then which function to call, right? What is the aggregation function that is going to be used? Let's imagine that we call sum on it. And so in this case we would add, we could call max as well, find the most frequent one. In this case, this particular example was done with a sum function. So for each of these, the remaining values will be tallied up. But then when the resulting data frame is assembled, it's not assembled back the way Groupby would, where after the aggregation function, this effectively becomes the index. That could be done. That would be a multi-index, but that's not what the pivot table does. Since the pivot table has a concept of a distinct rows and columns, now it lays them out by saying, well, I'm going to put A, B, C, and D, the unique keys of the row index as my index, and then the unique ones of the what you told me are the columns in this dimension, and I will drop the values that I have in there, filling as necessary the remaining ones with not numbers, because obviously nothing guarantees that from your data set every possible combination will exist. So in this particular case, for example, we had data such that this combination of 4 rows and 2 columns has 8 possible combinations, but we only had 7 subframes, which means after aggregation, we only have 7 values to work with. And so the remaining value will be filled in by pandas with a not a number. So there is one more little group by puzzle left at the end of this notebook, but in the interest of time, I encourage you to play with that one on your own. Because at this point, we're going to conclude our section, this section, by taking a very, very quick look at how joins work, and we'll do a little bit of a demo, in the next one. So joins are the syntax that Pandas uses for. I'm sorry, merge is the syntax that Pandas uses for joins. Turns out that Pandas also has a join method, which is sort of a limited version of merge. And in this class, we're going to focus on using merge, which is the more general one. But think of merge in Pandas as what the SQL join operation would be. And the generic syntax is that you have one data frame and you merge it with a second one, producing a new data frame, with very similar semantics to SQL joins. You have the option of selecting an inner or an outer join, a left and a right join. And so the general syntax of the merge method is that you specify how to do it, with how being one of these options, and on what key do you key the first data frame. So left on which column label from the first data frame are you going to use, and then which is going to be the join column on the second one, on DF2. So left on means this one, which column from this one do you want to use for the join, and right on means from this one, which is the column that you're going to use. And so in the final section afterwards, we'll do a quick review. Of joins. But at this point, with these 2 lectures, we've covered a fair amount of the core of Pandas. Today, we went over string operations, adding and removing columns, especially as a tool for sorting operations, accessing lock, using the lock accessor with indices. And then finally, we spent a lot of time diving into the details and power of Groupby and its sort of cousins, which are pivot tables. And we took a very, very quick look at the merge method, which we'll illustrate next to wrap it up. Those of you who are interested really in the details of data structures, there's a few extra slides here at the end of the deck that we encourage you to take a look at if you're interested in learning a little bit more about Pandas, but they kind of contain some extra technical detail.